a piece of paper that I asked you to pair the pages according to it. Because I said that was going to be like a content page for your file as well. So right now, if I get a pencil and look at it, okay, what chapters will be tested for review tests from the content page in the textbook? The whole of whole numbers definitely is in your review test one. You can hear, right? You really need to see. So review test one. I wrote here test one. You can just write test one. So you can ask yourself now, okay, numbers to 1 million, numbers to 10 million. Really, you can spell million properly. Do the numbers. Everything's got to do with that first chapter, including comparing ordering numbers, including number patterns, including rounding, including estimation. Then you move on to the next chapter, chapter 2, four operations of whole numbers. Multiplying by tens, hundreds, and thousands. Okay, this most of us found it quite easy. Once you know the pattern repetition, be okay. So I would say this is quite okay. Most of us are alright. Then this is the one multiplying tens, hundred, and thousand, then dividing by tens, hundred, and thousand. Then order of operations. I cool with that. Is that okay for you? Yes. After you solve out the paper. Are you okay with order of operations? Maybe the word problem part is a struggle for many of us. But look at the amount of learning objectives that will be tested as well, not just word problems. So the whole of chapter 2 has this portion down at fractions. So what exactly about fractions we will be tested on? First one, division of whole numbers and fractions is what we're discussing about. Today we're going to touch on converting fractions to decimal. Tomorrow there's a game we are going to play for fractions to decimal. And then addition of subtraction, addition and subtraction of fractions, whole numbers and fractions, mixed numbers, and different kind of fractions. That means I can add fraction to fraction, add improper fraction to improper fraction, mix number with mixed number or mixed number with proper fraction. So basically, all the way to here, adding, subtracting mixed numbers. This is all that will be tested for review test one. Okay, then the next one will be in the next term. Right now we are here. Division of whole numbers and fractions. Converting fractions to decimals, that's what I'm going to touch. Converting fractions to decimals is something that we learned in coming form before. Okay, now, so page 46 is the page. I'm going to share my screen. Later on, I remember promising that I will show you the how I got the trick, right? I'll tell you that later. Okay. So this is the one on page 50 of the book. And then at the front, actually, there is this story.
Here.
Peter, what fraction of the donuts are chocolate donuts? Herm, 6/10. My mum has cut the cake into 12 equal slices. Ravi, what fraction of the cake do you have on your plate? I have 1/4 of the cake on my plate.
Okay, so it turns out whatever I said just now. Now that I unmute. Yeah, I'm mute on my phone. Yes, thanks. Yeah. Just now I forgot to publish. So whatever I said just now I didn't manage to. I guess never mind. Now, so I was saying, now that as for 5, there are more than one way to solve problems. So I wrote here method 1 and method 2. Yesterday when I was writing this, I intentionally left some space for method 2. Then I want you to actually think about it. I remember saying, okay, so answer will be asked. But I didn't bring a worksheet. Never mind. Now, so I want you to be able to see and ask yourself which one works better for you. So the second method we were discussing yesterday, I know that the statistic is longer. So if I use the statistic, the length of the statistic, and I divide it by the candle, I should get the relationship. How many times the answer, which is how many times is it long as the candle. So if I take the statistic divided by the candle. So the statistic is 14, the candle is 4. So in other words, it's 14 divided by 4. And I can simplify this by divide by 2, divide by 2, numerator and denominator. And I get 7 and 7 halves. And I can change it to a mixed number, 3 and a half. Okay, so these are the two different methods. Now I need you to indicate in your work which one you like more. This one or this one? Or if you're okay both with like both, no problem. Now, when we were trying to explain it the first time round, we draw out the statistic. And we draw candle, 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 one whole candle, one whole candle, one whole candle. Eh? One whole candle means too much. So we take part of the candle. And most of us are able to find out that we are able to tell that 2 centimeter means it's half of a candle. So that's how we got it. We got it by drawing it out. Which is possible for questions where the number is not very big. Like 4 and 14 is okay. Like 6 and 15, 15 maybe a bit more challenging. If I want to draw 15 balls and I draw one by one, it's going to be tedious. So all of you is 6 meters. Divided by 15 balls, this was the fraction. So it should be 6 out of 15. In simplest form, divide by 3, divide by 3, I will get 2 feet per liter. It's okay? Is it okay? Okay, then we move on to the next part on which one do you need? This one? This one. Okay, then we move on to the next item, which is converting fractions to decimal and decimal to digit. Yes. Let's see which one. The 3? In what way? It's too bright? Okay. Marianne, can you turn off the first 2 row of lights? Okay, later on I'll use pen, okay? So it'll be darker. Better? Yes? Okay, now we're going to move on to the next part, which is fraction to decimal, decimal. Okay, so I'm back on my textbook, and the relevant page is here, page 52 and page 53. Now, in the textbook itself, it shares with you, in a way, recall what we learned when we are primary 4. There are three methods, sorry. Three methods shared with you on how to switch from fractions to decimals and decimals to fraction. Now, three, because it is a fraction that is like a mixed number or improper, that's three. So this is page 53. And then page 52, the two methods are shared here. It says here, the story goes as a 3 kilogram cake is shared equally among 5 people. How much cake does each person get? Express the answer in decimal. Okay, so this 3 kilogram cake shared equally among 5 people. This is not new. It's the same story as just now. But now instead of fraction, you want decimal. So the same steps, 3 divided by 5, 3 divided by 5, 3, convert to fraction, 3/5. So method number 1, get to 6/10. Why is it that the equivalent fraction where denominator is 10, 100, 1000? You know? Why must the denominator be 10, 100, 1000? Yes. Uh, uh, that is a perfect answer. You're absolutely right. Because decimals goes back to your whole numbers. Because in whole numbers and in decimals, your place values goes by tens, 100,000. Right? So yeah, so in what do you call a fraction that is me a fraction that is in tens, right? So this will be called the place value of this will be called if it's 10, 10 means 10. So this one will be tens. Familiar? Uh-huh. And then you have 100. So 100 is 100. So this one is 100 with a THS at the back. So if I were to draw my place value chart in million, which previously we learned million, huh? Space, 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 space. So, quick recall: million, 100,000, 10,000, 1,000, 100, tens, and ones. That's whole number, right? Then we start to have the decimal point. This one. 50 cents come in, 0.5. Then you have the small letter tens, the small letter hundreds, the small letter thousands. And it can go all the way to the other direction. So the amount of money gets smaller and smaller if you go the other direction. The fraction of the cake that gets cut becomes smaller, right? So that is this side. So decimals definitely 10, 100, or 1,000 and beyond. Okay, that's a quick recall. So the other method is long division. This one is very important. So 3/5 is 3 divided by 5. I don't stop here. I don't put remainder. For decimals, you continue to divide until you finish. What do you mean until you finish? I will insert a decimal point. That means I can no longer divide. Usually long division will go remainder. There's a remainder, cannot divide. But now that at primary 5, primary 4 and 5 we learn decimals. So we know that we can go up to in between numbers. So 3, I cannot divide by 5. I will insert a decimal point here, top up the 0 at the back, then I can continue the long division. Now, looking at the examples here, the who do you think, which one? Who, if you feel so, please raise your hand. You like method one. Okay. What method two? Okay. Who's okay with both? You like both? Okay. Good. Now, that's the key question. The most important question is when to use which one? Which one's better? Is it always this one works? Okay. Now, in your book, there's an example already. Question number. Question number what? Question number two. Why do you think the choice made here is method one? Because all the denominators are factors of 10, 100, 1,000. Okay, what do my factors is I can multiply and then convert it to 10, 100, or 1,000 easily. Okay, so what are the options? I can times 2, times 5, times 4, times 135. What else do you think can times? These are factors of 10, 100, 1,000. If they are factors of 10, 100, and 1,000, I can convert easily to the equivalent fraction easily and then convert to decimal easily. These are all factors of 10, 100, and 1,000. 5, 2, 4, 125. What else? Any other factors of 1,000, 10, or 100? Don't know? You don't know? So for 10, 10 can be 1 times 10, 2 times 5. Anything else? 10 times 10. Oh, that's 400. So 400 is 10 times 10, 1 times 100, 2 times 50. What else? Yes, Marianne? 4 times 25. Very good. What, anything else? 5 times 20. Is it okay? Then for 1,000, 1,000 I can 100 times. Okay, 100 times 10. And what else? 1 times 1,000. Okay, what else? Yeah, but if your decimal, if your fraction is already denominator is 10, I won't bother. You know, if my decimal is already in 10, if my fraction in the denominator is already 10 or 100, I won't convert to 1,000. 5 times? 20 times 140. Okay. 4 times 250. Okay, true. Very true. But honestly, if I have 4, right, I'll just times 25. I won't bother times 250. I just change it to 100 is good enough. Yes. 400 times 5, 200 times 5. Okay, that's very true too. 200 times 5 also can. 4 times 250 also can. 25 times 40 also can. But honestly, I won't use this because if they are already 100, I can convert to 100 already, I won't convert to 1,000. What's one more? One very special one that doesn't appear in 10, 100. It's here, it's here, it's here. Yes, that's very good. 8 times 125. Okay, so the shortcut in our workbook will be, before we go to bed. So now can you tell me, why do you think Question 3, you are using long division. This person is putting here as long division, not the finding equation one. Yes. Yeah. Because you will end up having to round to 10. What do you think you will end up having to round it? Look at the denominator. Is this possible to convert to 10, 100, or 1000? No. That's why you will choose long division. Understand? Okay, so here's the shortcut. I'll tell you, in the textbook workbook is very helpful, very guided. It shows you in the work which method to choose. It helps you to choose which method. However, in the exam time, like this page, you can already tell which method to use. But in the exam time, the exam paper is not going to tell you use method 1, use method 2. You have to decide which one is going to be better. So look at this one, and the shortcut here is at page 59. The shortcut here will be, I will ask myself whether I times 2 times 4 times 8 times 5 maybe times maybe what else there is what about that now? Times 6. No. Times 2 times 4 times 5 times 8 times 20, maybe times 20. What else? Huh? Times 25. Why? Because these are all possible ways to convert the denominator to 10, 100, or 1000. Okay. Okay, very good. Times 125. Any more? Times 50. Okay, very good. Okay, so the following questions will be asking me to convert easily from fraction to decimal. I just have to pick any of these that can help me to convert to 12 times. I'll choose times 2 times 2. Then I will be equal to 6 out of 100. So converting to decimal, looking at the shortcut. If you need further explanation on why this conversion works, you have to go back to primary 4. It's in our textbook. Primary 4 textbook. Or you can search my channel to find the primary 4 material. So the number of zeros in the denominator is a clue to number of spaces that you have after the decimal point. So I put 6 here and then 106. Now looking at 25, I will choose times 4. So I will choose 40. Now at the same time, I'll show you how it works. If I multiply by times 4 times 4, actually, if you see, the right on top here. 25, okay, times 1 will still be itself. You have to remember, anything times 1 will still be itself. That 1 actually can be 4 or 4, 2 or 2, 3 or 3. So 14 be like this. That's how it goes. Then I convert to 100. 14 times 4 is 64. Is that correct? Yeah, I think I made a mistake. No, it's not 64. Better to do calculations. 56. There goes my poor method calculation. Never eat vitamin today. Brain vitamin. You know what kind of brain vitamin I would eat? Like some funny jokes that fuel my brain. Or maybe watching Aiden dance again. You will fuel my brain and energize my brain. Right? Aiden do a dance together with Kiras. Our very own BTS. How you don't like BTS? Ah? Hey, chill, chill, chill. Hey, chill, chill. Not dancing here. Doing maths here, decimals. Very soon, the next topic we'll dance. Okay? We used to dance for the geometry. Yeah, the properties of angles. Okay, like the next one. Next one. Okay, I'll move on a little bit. One more example, and then we'll go on. This is quite okay, right? Okay, then the last one. Okay, you think you can do? All right. Okay, so DIY. Yeah. DIY. It's not a lot, just 4 more questions. We have quite a bit of help already. Okay, 58 times what? Just yes. Most of us already, the clues are given already. So I can do 125 times 5, that would be 5. 625 out of 1,000. So convert to 0 point space 625. Yeah. Last year when we used to do the dance for acute angle obtuse. Have you seen the video of the funny video of the no? Okay, later I show you. Okay, so wait, got this already? Which one? Yeah, only 2 minutes. I show you the calculator one first. Next time I'll show you the funny uh geometry video. And okay, the last one is times what? The last one is times 8. Okay, quite right, eh? Okay, now move on to this one. This one is a difficult one. Yeah, anybody feeling tired already? Just one, okay? Just one. No. That's the previous page 59, okay? Today is a CCA day. Yeah, today is a CCA day, so until page 59 only, okay? Okay, yeah? That's page 59. Okay. Alright, I will do this part tomorrow instead, okay? Alright, so we choose. Okay. I show you the calculator one. So tomorrow I've already booked the computers. We are going to try out this new adventure and also okay. So this is called the Adventure Island. This is where I got the secret. Okay, so tomorrow we'll get to use the calculator and then get to use the computer, then explore this calculator island. There's some fun, interesting stories. Now, so why does it work, right? Here. Here. Okay, so this was the one that I was sharing with you. Here are some magic tricks you can use on your calculator. So here got some examples. Okay, the one that I did with you is guess your friend's favorite number. Okay, then this one is guess the number rolled on the dice, and then guess your friend's birthday. So these are the tricks that you can try on the calculator. Okay, so exactly why this works. Remember the steps, right? This was the steps. And so the trick, how come I can use the trick? Alright? I only look at so this was the start. I think whatever answer you got to yesterday, I just ignore the last two digits and then I subtract one from the remaining number. So like for example, if the final screen shows this number, I'll just use the first three, the last two digits and then I subtract one. Now exactly why does this work? Okay, later you can go and tomorrow when we try the adventure island, then you can. Okay, this is the explanation. Got to do with order of operation. A bit quite a difficult thing for you to understand, but there's a reason why it works. Okay? Okay. Enjoy your CTA today. See you tomorrow. Today is CTA day, right? Why is it not enjoyable? Okay, wait, I end first. Sorry?